A very good evening to all of you. I, Rithi Chen from Atal Innovation Mission, Niti Aayog, warmly welcome all our young innovators tuning into today's Knowledge Hub session. This is the third episode of season 4. And in today's session, we'll cover how can we accelerate our innovation with the Tinker Blocks? This is the third session of the series that one of our regional mentors of change, Sri Kiran Kumar, is taking up. That how can we use Tinker Blocks for smart tinkering, for rapid prototyping, for accelerating our innovation. And we are honored to have with us our award-winning regional mentor of change, Kiran Kumar sir, and he's the innovation leader with 29 years of experience, known for shaping ATL tinkerpreneurs, mentoring young change makers, and driving technology-led innovations across country. And he'll be guiding us today on how to transform ideas into working prototypes within minutes, an unmissable opportunity for all our budding innovators. So, without wasting any time, let's invite Kiran sir to learn more. Over to you, sir.
Thank you so much, Riddhi. Thank you for the introduction and for setting the context. Very happy to be back again. Good evening, everyone. As Riddhi just mentioned, this is the third session of the Tika Block series. We had two sessions earlier on 21st November and on 28th November, where we covered quite a few things. We learned what are Tinker blocks and what we can do with Tinker blocks in the first session. In the second session, we dive deep into learning how we can build the Tinker blocks. And we even saw how to rapidly prototype an application using a few Tinker blocks. We had an opportunity to look at a live demonstration as well. So today we are going to carry the journey forward and explore a few more things. Today we are primarily going to look at some of the other applications that you can build through Tinker Blocks. Many other applications. I'll give you more examples. Apart from that, I'm going to show you how we can build virtual Tinker Blocks, which are basically software oriented or building blocks, apart from the physical Tinker Blocks we have seen so far. And finally, we will also see how we can accelerate innovation by leveraging the existing Tinker block-based applications to build new applications. So rather than reinventing the wheel, you will learn how to build on top of your previous work or previous projects or the existing building blocks that you already have built, right? So with that, we'll get started. So if you have missed my previous two sessions, here are two QR codes. You can go ahead and scan them and watch them later on. But don't worry if in case you have missed watching the first and the second session, I'm going to do a quick recap so that you can understand what I'm going to talk about today. But later on, I would encourage you to go back and watch the first and the second sessions as well. All right. So let's keep moving and let's go to the next session. Okay, so quick recap. What are Tinker blocks? Basically, Tinker blocks are a rapid prototyping toolkit that students themselves can build on their own. It consists of both physical and virtual Tinker blocks, and it helps you to build rapid prototypes of sensors and actuator-based applications, IoT applications, robotic or AI or augmented reality-based applications. And you can build this prototypes in just matter of minutes rather than taking like hours, days, or weeks to build an application. And the biggest challenge that most of the ATL students face today is the steep learning curve that is involved or the technological complexity that is involved in tinkering and innovating, because many of the electronics, you need to really have a good understanding of what those electronic components are, how do they work, what are their pin configurations, how do I need to connect the wires and all of those. So with Tinker blocks, all those challenges are taken away from you, because once you build the blocks, you don't have to worry about the electronics and things like that. So if a senior student who is already aware of electronics and things like that can build the blocks, they can make it available to the beginners, and the beginners will have a lot of fun building practical applications, prototypes, and they can convert their ideas into working prototypes in just minutes. So it will develop greater interest for students to tinker and innovate. And at a later stage, if you want to learn more, then you can delve deep into the technologies, how an electronic component works and things like that. But for a beginner, this Tinker Blocks is really a fantastic tool to get started, right? So that's what Tinker Blocks are all about. And last week, we also talked about the four basic types of Tinker Blocks: the sensor block, which can contain any DIY sensor or actuator, a sensor device, an actuator block, which can contain any DIY actuator, like a buzzer, and a power block, which is like the heart of the entire Tinker Block application because it provides the power or the power supply to all the other blocks. And the processor block is one which is like the brain. It contains a microcontroller like an Arduino or a Node MCU. It can have Wi-Fi connectivity. It can communicate with the virtual Tinker Blocks as well. And it is like a bridge between the virtual world and the physical world. And it takes commands from the virtual blocks and passes it on to the sensor or actuator blocks. And similarly, it can do the job vice versa as well. So like take the data from the sensor block, relay it to a virtual block and things like these. So if you have these four basic types of building blocks, you can build a variety of Tinker block applications and very rapidly. All you need is more variety of sensor blocks and more variety of actuator blocks. And all you have to do is just plug and play, and you will be able to build practical applications. Like you see here, there's a temperature block and a buzzer block, both of which you can just plug onto the power block. And on top of it, you can also plug in a processor block. And you just connect two patch cards, and your fire alerting application or a temperature monitoring application is ready. And you can just have your idea converted into a working prototype in just a minute or two. Isn't it fun? Isn't it amazing if you can do this? So that's what the promise of Tinker Blocks are. So all this we saw last time. How do we snap multiple blocks in place, and you can build applications very quickly. And we also saw the inner workings of the Tinker Blocks. How are the actual Tinker Blocks constructed? What's inside it? When you open this block, how does the block look like on the inside? What components are actually affixed on these blocks? How do we actually cut and make these blocks? So, and how are the sensors placed? How are the actuators placed? How is the wiring done? All of these we saw. For example, here you can see the example of a fire sensor block, where the fire sensor is placed here at the bottom, and also an LED, and then there's a male barrel connector, a female barrel connector, a switch to operate the entire block, and there's a data pin as well. So all of these are wired up with a simple wires, and boom, if you can just build this block in a few minutes, then your block is ready to function. Similarly, we saw an actuator block. How do you construct an actuator block? For example, here is the case of a buzzer block. How do you build a buzzer block? It's very similar to the sensor block. Instead of the sensor, you just put the buzzer here and connect the positive, negative, and the data pins. That's pretty much it. Rest of the circuitry is same. So once you build it, you can reuse the circuitry again and again rather than reinventing the wheel, building things again and again. Right? We also saw how to build the power block last week. So it's just that you have to have multiple female barrel connectors, all connected with each other, all the positives connected with each other, all the negatives connected with each other. One of those barrel connectors can act as the input, to which you can plug in a AC to DC 5 volts adapter, and all the remaining five barrel connectors can act as the output. That means you can connect any sensor block or an actuator block or a processor block to them. And all those other blocks will get power supply from this block, right? So this is what we learned about the power block last time. And then we also learned about the processor block, the brain behind this entire Tinker block application. Here we said we will put a node MCU, which is a microcontroller, and we take the data pins D0, D1, D2, D3, all the way up to D8, and connect them to different data pins on the block. So anybody can connect any data pin from any sensor block or an actuator block to one of these pins, and the connection is complete between the microcontroller and the sensor device. So this is how the connections are made. And you learned all of these blocks last time, right? How to build these blocks. And we also showed you how to build a fire alerting application. If there's a fire, The fire block can recognize there is a fire, and the buzzer block will sound if the fire is detected. And all you have to do is put some Arduino code into this processor block, right? And if you bring a flame or a fire with a matchstick, lighted matchstick, and bring it close to the fire block, the buzzer block would start buzzing and start making a loud sound. Okay, this is what we saw. I hope all of you remember the demo that I showed you last time, right? So now that we have seen what was done in the previous 2 weeks, now let us look at what else you can do with Tinker blocks. How can you rapidly prototype with Tinker blocks? Of course, we showed you one application of rapid prototyping last week, but we will see a few more examples today so you get a understanding of what are the different types of applications that you can build with Tinker blocks, right? So one is, let's say you want to automate the operation of the fan or a light in your home. And let's say you want to do it based on the temperature. Let's say the scenario is if the temperature crosses 20 degrees, then you want to turn on the fan. Or it could be even like 25 degrees or 30 degrees. You can configure the temperature, and normally the fan can be switched off. And when the temperature crosses, let's say 20 degrees or 30 degrees, then you turn on the fan. So what does it require to build this? It's just a temperature block, a fan block, a power block, and a processor block. You just plug all of them together, and you put an Arduino code into the processor block, which will check the temperature reading. And if the temperature is more than 20 degrees, it will turn on the fan. If the temperature is less than 20 degrees, it will switch off the fan. That's all it is. Okay. So the code that you're writing into the processor block, that we call as the virtual block. I'll come to the virtual block a little later, but for now, it's suffice to say that this is how you build a simple home automation application, which is a fan that is controlled by the temperature of the room, right? So you could just build a simple prototype like this in just 1 minute. Or take the example of a garden watering system. Let's say you're not at home, but maybe you're gone on vacation for a few days and you have multiple plants in your home. You don't want the plants to dry out and die when you're away. So what can you do? You can use a Tinker block, build a small automated garden watering system. You need a soil moisture block and a pump block along with a power block and a processor block. You plug all of them together, write a small piece of virtual block code, put it into the processor block. So what does this application do? The soil moisture block will look at the moisture content in the soil. If it feels that the soil moisture in the soil is low, or if the soil is dry, then it will make the water pump block turn on. That means the pump will start pumping water, and it will spread the water around the plants, and then the plants get water. And when the plants get water, they are healthy and they will survive even when you're away from them. So you can pretty much automate your garden with a simple Tinker blocks, right? Very simple. You don't require much time. Just plug these 3 blocks, 4 blocks, and you're done. So simple, right? Let's take one more example. Let's say you have a constrained parking area in your home or in your apartment, and you want to make sure that when you're parking your car, it's safely parked and you don't go and bang against the wall or some fence or something like that. So you can just build a very simple parking assistance system using an ultrasonic block and a buzzer block and an LED block. Okay, just plug all these blocks to the power block and add the brain, which is the processor block on top. So how does this work? The ultrasonic block looks at the distance to your car. You mount this at the back of the parking space where you are trying to park your car. So the ultrasonic block will look at what is the distance between the car and itself, and if the distance is more, it's fine. But if the car comes very close to it, then it'll turn on the lights and it'll also start buzzing. Then the driver gets an alert saying that, okay, your car is very close to the obstacle or to the fence or to the wall. Please go move forward or back off. Don't come too close, otherwise you're going to bang the car against the wall. Okay, so this is another very simple application that you can build with just 1 sensor and 2 actuator blocks. One more example. Let's say you want to build a home surveillance system, a system in which you can monitor who is at the front door of your house and things like that. So there are multiple ways to do this. One is you can put a camera, and the camera block can actually monitor who is at the front door, or you can also use a motion block, or you can use a combination of camera block and motion block as well. What does the motion block do? It will have a PIR motion sensor inside it. So if there is some movement in the vicinity of the front door of your house or somewhere else, even it could be even inside the house. So if there is some movement, it will detect it and it will turn on the LED, it will turn on the buzzer, especially when the house is locked and nobody is around. This motion sensor and the camera block can actually ensure the safety of the house. If there is an intruder, it will warn the neighbors and the intruder may run away. So, so that is how you can build it. And with the camera block, you can also get a live feed to your smartphone where you can see who was there at your front door, what were they doing at the front door, and things like these. So you can build a very simple home surveillance system with just plugging in like 3 or 4 blocks. Imagine if you had to build all the circuit to make this system work. It would take you multiple days, maybe multiple weeks to build this. With Tinker blocks, things become so easy. You just have to plug, and then whatever application you want to build, it's ready in just a minute or two. That's it. Very simple. All right. And one more example, if you want to build a, let's say, some kind of a hazard monitoring system, like something like in your kitchen, there could be fire, there could be smoke, or there could be gas leakage. All of these are hazards, right? So how do you secure your kitchen? You can just build a Tinker block application, which consists of a fire block, a smoke block, and a gas block. All of them have their own sensors, a fire sensor, a smoke sensor, or a gas leakage sensor. And you also plonk an LED block and a buzzer block and a processor block on top of it. And then you have your hazard monitoring and alerting system ready. So if there's a smoke, the smoke detector detects it. If there's a gas leakage, the gas leakage block will detect it. If there's a fire, the fire block will detect it. In either of the cases, the LED will start blinking and the buzzer will go off, alerting people in the house that there is some hazard, and they can come back and they can come take a look and fix it. So imagine if you had to do all of these from scratch every time. You have to build this application. It take you a lot of time. With Tinker blocks, it's very simple, very easy, isn't it? Or you want to monitor the weather. Let's say you have a greenhouse, or you're building a project for a greenhouse where the temperature and humidity and watering levels of the plants are tightly controlled. In such an environment, how would you monitor the weather condition or the environment in the greenhouse? You might want to use a temperature block. You can also use a rain block, because if it's raining outside, the temperature could come down, the moisture or the humidity levels could go up, and things like that. And if the temperature is high, you want to turn on the fan so that it cools down the entire greenhouse. You could do many things in a greenhouse to control the entire environment. So whatever parameters you want to control, you take these necessary sensors like a temperature sensor block or a rain block and a fan block, plug them all together, and your weather monitoring system is ready. So in just a matter of minutes, you can build any applications like these. So this is how we build a variety of Tinker block applications. Now let me stop sharing my screen and show you how I have actually built 1 or 2 applications um, uh, with the Tinker blocks that I have. Okay, so let me show you this small Tinker blocks that I have put together. Can you see this? This is the temperature sensor block here. This is the fan block. This is the power block, and this is the processor block. Okay, you just plug these blocks together. You can just take them out, or you can put them back in, and your application is ready. So this is how you build a simple application by just plugging in the blocks. I showed you how to plug these blocks earlier. And let me show you one more demonstration of how we have built another kind of application. This is an application in which there is a soil moisture sensor block. You can see it here, the one on the yellow color, and this has 2 leads coming out, and they actually go and connect to this temperature sensor lead, the soil moisture lead. You have to dip this into the soil so that it can detect whether the soil is dry or wet. Okay, so these 2 wires will go out of the block, and you can plunk this anywhere where you have a soil or a flower pot or anything. Okay, so this can monitor the moisture content in the soil. And after this comes another block here, the orange block here. This is called the pump block. Can you see this water pump here? This is not mounted inside the block. It's mounted outside the block because you have water flowing through this and you don't want the block to get wet for any reason, right? So we take two wires, the red and black wires, and connect it to this water pump here. And what we do is we take this block and put it into a bucket of water, and the outlet of the pump will be connected through a water pipe here to the flower pot or to the plants. So pretty much when the soil is dry, the pump will switch on and it will water the plants. And when the soil is wet, the pump will stop pumping. So this is how you can build a simple application, a garden watering system, an automated garden watering system with the 4 blocks. All right. So this was a simple demonstration of the blocks. Now let me go back to the screen and let's continue from where we left off. Okay, hope you can see my screen again. Let's go to the next slide now. So now that you have seen a few examples of Tinker blocks, the kind of applications that you can build the blocks, but I've shown you mostly the physical blocks so far, right? I've shown you the 4 types of Tinker blocks, which are basically the power block, the processor block, and the sensor or the actuator blocks. So by plugging all of them, you can build different kinds of applications. But I also told you something about the processor block. You need to write some Arduino code into it, and you need to upload the code into it. That is the software part. So that is the software part which is very important, because without the software part, the actual hardware may not do much, right? Just by connecting a sensor block with a power block or a processor block doesn't mean anything unless the software also controls how the hardware functions. So this is where we need to integrate the physical electronic components with the software, right? The software is your Arduino code, a simple Arduino sketch that you can build, you can write using an Arduino IDE or an Arduino cloud editor, and you can upload it to the processor block. The processor block has a node MCU, a microcontroller, which I mentioned to you earlier. So this is how we have the first step in building a virtual block. But there are many other virtual blocks. But let's look at what it takes to build richer Tinker block applications. Okay, so if you have a Tinker block applications, one thing is, of course, as I said earlier, you can build a plug in a few Tinker blocks, and then you can write a simple Arduino code. And how do you, what do you do after that? Some of them can be an Arduino code which will automatically trigger a buzzer when a fire is detected, or it can turn on the water pump when soil moisture is detected. Those things are fine. It automates the whole process. But let's say you want to visualize the sensor data. What can you do for that? So we don't have a mechanism in the physical Tinker blocks to do that. Of course, you can put an OLED display block or an LCD display block. You can do that as well. But if you want to experience that, you want to visualize the sensor data on your mobile phone or in a web application, then you need to have virtual blocks. So the virtual blocks are software-based blocks, which will help you do multiple other things that the physical blocks may or may not be able to do it on their own. That is, the virtual blocks help you visualize the sensor data in variety of forms. For example, in the form of graphs, charts, or it could be in the form of a meter or a gauge, or it could be in multiple graphical formats. So you can build software-based blocks to visualize the sensor data. Or you could also build software-based blocks to control the actuator devices. For example, remotely from your mobile phone, you want to switch on a fan or switch off a fan, or you want to turn on the buzzer or turn off the buzzer. You need a software component, and that software component could be a mobile app running on your mobile phone. Or you could also automate some of the actions from your software itself. If the automated block, the automation block can receive the sensor data, and based on the sensor data, it can trigger some action with some of the actuator block. For example, I told you earlier about the temperature controlled fan application. So the automation block can receive the data from a temperature sensor, and then we can have a rule in the automation block which will go and trigger the actuator like a fan, and the fan will start rotating if the temperature has crossed a preset limit. So you need automated actions. So virtual blocks can handle visualization of sensor data. It can control the actuator devices. It can automate some of the actions. Virtual blocks can also do something more. For example, you can receive all the data from the sensors in the Tinker Block application. You can store it in some database. You can analyze the data. You can make some sense out of it. You can actually visualize the trends. You can get some insights about the data. So you can do pretty much data analytics and things like that. You can also do some machine learning on top of the data. You can apply artificial intelligence models or algorithms to do something with the data. All of these are possible with virtual Tinker blocks. So Tinker blocks or virtual Tinker blocks are basically the software components that can be integrated with the physical components. So let me show you a few examples of the virtual Tinker blocks. So first of all, on the left side, you see the physical Tinker blocks, and on the right side, I've given you an example of a few software component, software or the virtual Tinker blocks. These are not the only virtual Tinker blocks. You could have many other types of virtual Tinker blocks, but I've just given you a few examples. Okay, so what is the distinction between a physical Tinker block and a virtual Tinker block? The physical Tinker block is something that you can touch and feel. It's in 3 dimensions. It's a physical cube made of cardboard and things like that, or it could be even 3D printed, and it contains electronic circuits in them, right? And you connect the patch cards and things like that. Whereas the virtual Tinker blocks are software components. You cannot touch them with your hand or finger, right? They are software components. You can experience them or you can interact with them through a mobile device or a computer or some kind of smart device. So the software building blocks or the virtual Tinker blocks mainly can handle data visualization, like viewing the data in a graphical form or a chart or a plot and things like that. Or you can interact with it. A chatbot is a good example of a virtual Tinker block. A voice activated application is a good example of a virtual Tinker block. Or a face recognition app is an example of a virtual Tinker block. So there could be a variety of virtual Tinker blocks. Let me run through some of them now so that you get a better understanding of what virtual Tinker blocks are. Okay, so I'll illustrate each of them with a very simple example. The first one we will talk about is called the device integration block and the server block. These are the most important and essential blocks when you have to integrate with many other virtual Tinker blocks. Okay, so the device integration block is nothing but the Arduino code that you write and you upload it to the processor block, right? So it's basically the Arduino code that runs on the Node MCU device, which is sitting inside the processor block. Okay, so for the sake of clarity, we call it as a separate block and we call it as a device integration block because a processor block is a physical block. The processor block is being a physical block, it doesn't have any intelligence of its own. The Node MCU device, which is sitting on its own, will not work unless you put some code on it, right? So that is why we call the Arduino code as a device integration block. The moment you put some Arduino code onto the processor block becomes intelligent and it starts working. And it can collect data from the sensors or trigger some actuator device. So that is why we need a device integration block. This is something that we have already exposed you even during the last session. We wrote a simple Arduino code and it could make a fire alarm application. But if you want to make your Tinker block work with many other software applications, then you need to integrate your device integration block with something called as a server block. A server block is not something that sits on your processor block. It sits somewhere else, somewhere on some computer or some server or somewhere on the internet. Okay, it can be anywhere in the world. And your device integration block has to communicate the data or receive the data from the to and from the server block over the internet. How does it do it? It can do it through a Wi-Fi connectivity because the Node MCU device on the process block has Wi-Fi. So it can communicate back and forth using Wi-Fi connectivity. And what does a server block do? It can take the data from the Tinker block application, it can store the data, and it can also send the data to other virtual blocks. And what are those virtual blocks? We will look at each of them very quickly now. So this is how, if you want to build a device integration block, you use an Arduino IDE, like the one I've shown here in this picture. Or for building a server block, you can build your own server application using some code, Node.js, or some kind of any web server you can use, or you can use IoT platforms, Internet of Things platforms. For example, I generally use a platform called ThinkSpeak, ThinkSpeak is a very interesting application. Many ATL students also use ThinkSpeak, and ThinkSpeak can be our server block. You don't have to build the server block. You can leverage an existing platform like a ThinkSpeak IoT platform as your server block. So it can take the data from the device integration block. It can store the data. It can process the data. It can do many other things. So the ThinkSpeak IoT platform can be a very powerful server block as well. Okay, now let's look at what else we can do with the virtual blocks. So we can connect a data visualization block with the server block. So what does the data visualization block do? It will help you visualize the data on your mobile app or on a web app and things like that. It will present to you in a form that you can consume in a graphical format. It can be in the form of a meter, it can be in the form of a thermometer, or it could be in the form of a gauge display, like a speedometer in your car. The needle moves. If the temperature changes, the needle moves on a speedometer, something like that. Or it can show it in the form of a lamp indicator, like turn on or turn off kind of indications can be shown in the form of a lamp indication. So you can present the data in whichever format you want. All you have to do is write some code and make that into your data visualization block. And that data visualization block can connect to your server block to get the data and present it. That's all. Any code that you write can be to represent the data, to present the data to the end user. That is called as a data visualization block. It's not complex. Okay. So again, we can use ThinkSpeak. ThinkSpeak itself gives you many data visualization widgets. You can use those widgets to build the data visualization block. Or you can build your own mobile app or a web app to build the data visualization block as well. And apart from that, I also mentioned about device control blocks. What does a device control block do? Device control block is basically, again, a software application which can be used to remotely trigger some actuator device. Let's say you have a buzzer connected to your Tinker Block application. You want to turn on that buzzer remotely from your mobile phone or from a web application. Then you can write a simple JavaScript or some HTML code and things like that, or a mobile app. And then when you press the turn on button, it sends a turn on command to the server block, which in turn sends it to the device integration block. And the device integration block in turn sends it to the buzzer block. So that is how the chain of commands will pass through and ultimately the device is turned on. Similar is the case for the turn off. So again, you can build your own device control blocks on your own. Any software that you build to control a device on the Tinker block can be called as a device control block. All right. And you can also write something called as an automation block. I mentioned earlier that if you want to detect fire and then automatically turn on the buzzer, then the automation block can be a simple code that you write. It could be in C, C++, Java, whatever, any programming language you can use, or you can use the ThinkSpeak. ThinkSpeak has a feature which will automate, using which you can build the automation block as well. It's called the ThinkSpeak React. So using the React feature in ThinkSpeak, you can automate the actions between the sensor events and the triggering the actuator. So this is another very interesting block that you can write to build very interesting, richer applications. And so data analysis block. I talked about data analysis block. What does a data analysis block do? It takes the data. What is the data? The data from the sensors are connected to your Tinker block application. That data is collected from the server block, and the data analysis block can go through the data, analyze the data, make some sense out of the data, and then it can tell you what was the maximum temperature in the month of November, or what is the correlation between temperature and humidity. It can plot these graphs and charts. So the data analysis block is very good in doing all these inferences. Okay, it can also give you some deep insights into the data. What is the pattern within the data and things like that. So you can do very interesting things, right? So you can plot a graph, something like this. It's a correlation between temperature and humidity. Or you can even build even more sophisticated applications with Tinker blocks. You can integrate a chatbot block with your Tinker blocks. Many of you must be familiar with the LandBot chatbot builder tool. All you have to do is build a chatbot using the LandBot tool and integrate it with the server block. And boom, you can start conversing with your Tinker block application as if you're talking to another human being. Or how do you converse with another person in WhatsApp? You ask some question and the other person responds. Or how do you converse with ChatGPT. Similarly, you can say, think a block, tell me what is the temperature, and the think a block responds to you saying the temperature now is 29 degrees Celsius. Okay, you can say think a block, turn on the buzzer, and you can type that command, and the Tinkerblock application will go and turn on the buzzer. So you can interact in a conversational fashion with a chatbot block. Okay, so you can use landbot.io kind of tool to build a chatbot block. Okay, I have very detailed tutorials for all of these on our Tinkerblock portal. I'll give you the link. You can go and find out how to build all of these virtual blocks on your own. The code, everything is given. So you don't have to worry how to build these blocks. You just have to copy paste and your virtual blocks are ready. Okay. Or you can build a face recognition block as well. Let's say you use teachable machine tool. A teachable machine tool is a very simple tool. You can use it for image classification at a rudimentary level. You can use it as a face recognition application also. And you show your face, and the face recognition block recognizes your face, and then it triggers a buzzer on the Tinkerblock application. If you don't show your face, maybe it will switch off the buzzer, something like that. You can decide how you want the face recognition block to be built. I have given you some samples in the tutorials. You can go through them, you can modify those blocks, and you get to build your own blocks. Whatever you want to build it. And the whole idea of building these blocks is to build it once and reuse it again and again in multiple projects, because you don't want to start from scratch for every project, right? That's the whole idea. So you can use teachable machine, or you can write your own JavaScript face recognition system, or you can use OpenCV, any of the tools to build a face recognition app. Or you can even build an augmented reality block. So we normally stick a something like a QR code. We call it as a zap code, and you just scan the zap code on a Tinker block, and it will immediately display the temperature reading or a humidity reading or some sensory reading on the block itself. So you can get an augmented reality experience. You can even use AR or VR headsets and visualize the data. So these are all really fantastic ways to interact with your Tinker blocks. It will almost seem magical if you can build an augmented reality block through which you can experience the sensor data, or you can control some actuator devices. And there is also voice activation block. So you can build a voice activated application. So if you can say that Tinker block, what is the temperature now? And the voice activation block will respond to you back in voice. It'll tell you what is the current temperature. You could say, Tinker block, please turn on the buzzer in your voice, and the voice activated application sends that command to the server block. The server block will go and in turn through the device integration block and the processor block, it will turn on the actual the buzzer. So that is how all of these work. Okay. So again, you can use a simple voice activation JavaScript or build your own application to do all of these. So what I'm trying to say is, if you want to build any kind of applications, you just need to integrate your application, whether it is a mobile application or a web application or a chatbot application, whatever it is, just connect it to the server block. Okay. The server block is nothing but your, like, it can be your ThingSpeak application, or you can build your own server block as well. And once you connect it to the server block, you get all the data. You can have two-way conversation with your Tinker block application. Right? So that is how you can extend the functionality of your Tinker blocks to do many, many interesting things. All right. So this is how you build. Let me show you another view of how the distinction between the physical blocks and the virtual blocks. So at the bottom, you see the physical blocks, right? And on top of it, you actually put the device integration block, which is nothing but the Arduino code which sits inside the processor block, and that communicates with your server block, and the server block can communicate with a data visualization block, or a device control block, or a chatbot block, or an AR block, or a voice activation block, or a Gen AI block, or a face recognition block, or a robotic block, or any type of block. You can go and build any number of virtual blocks. So there's no limit to how much you can do. It's all limited by your creativity, okay, and the kind of applications that you want to build, right? So Tinker blocks will help you extend and build your own toolkit and build any type of application you want, right? So now we have understood how we can use virtual tinker blocks and physical tinker blocks to build richer applications. We will look at how do we accelerate innovation using tinker blocks. This is the last part of our session today. So just pay attention to this very important concept. So if you want to accelerate your innovation, you don't start from scratch. You don't reinvent the wheel. You take your tinker block application, maybe one block you have built earlier, another block set of blocks you have built earlier, you reuse them in your third project. Okay, in the fourth project, you reuse all of them again. And the fifth project, you reuse more. So you build on top of your previous work rather than starting from scratch for every new project that you want to work on. So that is the concept of accelerating innovation. Okay, that is what is how we accelerate innovation. We can we can accelerate innovation or speed up our innovation only if we can reuse. If we don't reuse, then we will be slowed down because every time we are redoing the same work, maybe the last project we did, we threw away all the things. Then next project, you need the same components, you have to rebuild it. Rather than that, we build tinker blocks and then we use those blocks again and again. And sometimes we can use a complete tinker block application and we can take the complete tinker block application and just plonk it onto another tinker block application. And then you get something even bigger, right? I'll show you with the example of two applications. Let's say you want to build a smart greenhouse management system. Okay, this is a big project. It can do many things. So what can we do? Earlier we saw the weather monitoring system. We also saw the garden watering system. What if we take both of them and combine them with a few virtual blocks? Then we'll get a smart greenhouse management system application very quickly within a few minutes. Can you imagine this? So take this example of a weather monitoring application. Okay, let's say that it's packaged into one box. Complete weather monitoring application that you built earlier is ready. And then you also have the garden watering system. Okay, so this is another project that you have built. And let's say you put some device integration block on top of it, which is basically the Arduino code to make them work. And at the same time, this device integration layer also sends data to a server block. And the server block, what does it do? It will help you visualize the data. It will also help you control the data. And if you want, you can also add an automation block. And the whole idea is when you bring all of these together, when the weather monitoring system, the garden watering system, and the virtual blocks on top of all of them are integrated together, then you can build a smart greenhouse management system very quickly. So what does the smart greenhouse management system do? It monitors the weather, the temperature, the rainfall, and things like that. And it not only turns on the fan when the temperature is high, but also it can automatically water the plants in the greenhouse. So it looks at the soil moisture, it looks at the temperature, all of these parameters, and it decides, okay, I need to turn on the water pump now to water the crops in the greenhouse. And how much to water, for what duration to water the plants is all decided by your server block and your automation block and your device integration block. So you can write the kind of logic that you want in any of these software blocks, which will automate the entire operation of the greenhouse. So earlier it was only weather monitoring system. Earlier it was only garden watering system. By combining them, you build a bigger innovation now, which is basically the greenhouse management system. So very quickly, by reusing these building blocks, you have been able to build a bigger application now, right? That is the advantage of Tinker blocks. Let's see one last example. So which is basically an automated building, an automated hazard alerting and suppression system using the hazard monitoring system and garden watering system. You remember we built a hazard monitoring system earlier, which was basically had a fire sensor, smoke sensor, and a gas leakage sensor, and we also had a buzzer. What was it doing? It was just figuring out whether there's a fire, gas, or smoke, and it was alerting people through a buzzer and a light. That's all it was doing. But it was not putting off the fire earlier, right? Because it only had a buzzer, it didn't have a water pump. But if you see our garden watering system, it has a mechanism to turn on the water pump also, right? You can turn on the water pump based on the soil moisture. But in our case, in this particular case, we don't need the soil moisture, but so we can switch it off, but we can reuse the garden watering system because it has a water pump in it. And all we had to do is connect them with a few virtual blocks a server block, visualization block, control block, and automation block, and device integration blocks on both sides. And what you get an automated hazard or alerting as well as suppression system. So if there is a gas leakage or if there is a smoke, it will alert you. But if there is a fire, the water pump is also switched on so that it puts out the fire. So by taking the hazard monitoring system as the set of Tinker blocks, garden watering system as another set of Tinker blocks, combining them with a few virtual blocks, you have been able to build an automated hazard alerting and suppression system very, very quickly, right? So this is how you evolve your innovation over a period of time. You reuse rather than throwing away things and building from scratch. Okay, so this is how we build applications rapidly. Okay, this is how Tinker blocks will help you. Now I can quickly show you the Tinker blocks portal, about which I briefly talked about earlier. I don't know, how are we doing on time? It's almost 4:45. I can very quickly show you what we have, and then you can take a great deeper look later on. Okay, so this is the link to the website. So go to this website, sites.google.com/view/ATL Smart Tinker Blocks, or you can scan this QR code. This is a very comprehensive web portal where you can find a lot of learning resources, tutorials on how to build the physical Tinker blocks and how to build the virtual Tinker blocks. Okay, so if I were to click on this, it should open the portal. Let's see, it's coming up. Yeah, so this is the portal. Okay, so there is a live dashboard, there is some instruction. So you scroll down, there is some example, there's a video. You can look at this video. There are multiple menus here. You want to look at the tutorials to build the blocks, you can click this link. You can watch some of our YouTube sessions here. You can attempt the quiz. You can chat with the Tinker Block portal as well. It's an AI application. You can ask any question to it and it can respond. And there's also a Tinker Blocks challenge you can attempt. All right. So if you go to the Tinker Blocks portal, Tinker Block tutorial, there are lots of tutorials here. You can start right from what is a sensor and actuator to Arduino programming. Then how do you build a power block, processor block, temperature block, fire block, things like that. And how do you connect all of them together? There's another tutorial for it. Then how do you build virtual Tinker blocks? There are many examples. How to build a server block, device integration block, data visualization block, device control block, automation block. So how do you build a web-based one, a mobile-based one, voice activation block? So there are lots of detailed tutorials. All you have to do is go and click this link, one of these links here. And if you click, there's a detailed tutorial which will tell you how to build it. Detailed step-by-step instructions are given. All right. So this is how you build the physical and virtual Tinker blocks with these tutorials in hand. So just make sure to go through these tutorials and so understand how you can build your own blocks, right? It's pretty much self-explanatory. It's not difficult. And I would encourage you to start building your blocks. And so finally, to conclude, I would say the key takeaways from our 3 Tinker block sessions are: Tinker blocks enables you to do rapid prototyping. It hides the technological complexity of tinkering and innovation. You get higher level building blocks. You build on top of each other, which will help you accelerate your innovation. And you have a lot of online self-learning resources. You can scan the QR code and you go to the portal and you can leverage a lot of learning resources. It enhances your creative ability because you can focus more on your ideas, converting your ideas to reality rather than worrying about technology and electronics and things like that. And Tinkerblocks allows you to integrate with a wide variety of online tools, platforms, software components. You can build your own and integrate it with Tinkerblocks. So there are many, many interesting things that you can do with Tinkerblocks, right? And finally, if you want to attempt this quiz, feel free to do it. There are multiple questions here, about 10 questions. Scan this QR code, attempt this quiz to understand how well you have understood about Tinkerblocks. All right, and that's pretty much what I wanted to cover today. And thank you very much for joining today's session. And I hope you have understood what are Tinker blocks, how to build the Tinker blocks, how do you accelerate your tinkering or innovation projects. So feel free to go through the portal, And if you have any further questions, you can always come back and reach out to me. Right. So thank you, and over to you, Ritu.
Thank you, sir. It was indeed very knowledgeable for all our students. We have received several uh, questions, so due to scarcity of time, we won't be able to take a lot of them, but yeah, few of them will take up. Uh,
Uh-huh.
but I'll also like to mention that we are joined by one of our ATL team members, Arunima. She has recently joined us. So, yeah. So first question is, what key principles or mindset shifts define effective tinkering versus more traditional design or engineering approaches? I mean, one way we are talking about rapid tinkering, and on the other side we have more traditional design approaches or engineering approaches. So what is more effective, and what are the key principles or mind shifts that might find that effective tinkering?
Okay, so there are, of course, there is no one set way of one right way of tinkering. Every approach has its own pros and cons. See, if you're a beginner, I would say tinkering is hard for many beginners because they need to understand a lot of things. The learning curve is steep. And what happens with many students is when they find tinkering is hard, it requires a lot of learning and they don't have enough support, mentoring support, or guidance, they tend to give up. So that is why we use rapid prototyping tools like the Tinker blocks to help them get started with tinkering. Then they have fun tinkering, converting their ideas into working prototypes. But that is for the beginners. But the moment you are more comfortable with these, you understand how to work with Tinker blocks. Maybe at a later stage, you might say, I want to now learn more about technology. At that stage, you don't need Tinker blocks. At that stage, you can actually directly go jump in into electronics or the technology and start building your own projects. So there are positives and negatives. So the positives with Tinker blocks is it speeds up your tinkering and innovation projects. It helps you get started, jumpstart with your tinkering journey if you're a beginner and things like that. At the same time, you may not learn much about technology itself because we hide the technological complexity in Tinker blocks. But if you're building the Tinker blocks, you definitely still need to understand everything. But if you're a user of Tinker blocks, you don't need to understand technology. So you focus more on ideas and converting your ideas into working prototypes rather than worrying about technology. See, today we have AI tools like ChatGPT and all that, right? They magically do many things, but we have gotten used to it because it helps us save time. Otherwise, you could also do things manually, but it takes you more time, more effort, more struggle, and things like that. So it's always a trade-off between speed, the productivity that you can achieve, and your goals. What are your goals? So your tinkering activity, your techniques, the tools that you use should be based on your goals. What do you want to achieve at the end of the day? If you want to get your ideas to a working prototype quickly, please use Tinker blocks. If your idea is to understand technology in depth, Tinker blocks probably is not the right way to tinker. So there are pros and cons. Yeah, I hope I've answered the question.
So, one question is, given limited time and resources, how would you prioritize which tinker block or building blocks participants should master first?
Okay, that's a little challenging question to answer. See, first of all, I talked about four basic types of Tinker blocks. One is the power block, which is definitely required because without the power block, it's like the heart of your Tinker block application. If you don't have the power block, you can't do anything else. You need the power source. And you also need the brains, which is the processor block. Without the brain, nothing much will work. And then you need to have a few sensor blocks and then actuator blocks. The most common sensors and actuators that we find students using in the ATL is like the fire sensor, the motion sensor, the ultrasonic sensor, the soil moisture sensor, the raindrop sensor. So start with a few sensors like these and a few actuator devices like a servo motor or a DC motor or a water pump, and things like this. So it all depends on what kind of project that you want to build. So at least start with some 3 or 4 sensors and 3 or 4 actuator blocks. and then you start plugging in. As and when you need more blocks, you start building more blocks. And it doesn't take much time to build these blocks. All you have to do is take a kg cardboard sheet, cut it into pieces, make a cube out of it, reinforce it with a bit of cardboard, the corrugated sheets, either the plastic one or the cardboard one. Make some small holes and fix some electronic components in them and do the wiring. Maybe within an hour, you can build one block. The first time, it may take you little time to build the blocks. The second time and third time, you'll become so proficient that you can start building each block in about half an hour. And if you have a team of students working together, each of them can build one block each. And within one day, you can have multiple blocks in place. And the second day, you can start tinkering, connect the blocks, and boom, your applications are ready. Your ideas can be realized into a working prototype in just minutes on the second day or the third day itself. So there's no hard and fast rules. So the beauty of Tinker Blocks is it allows you to express yourself creatively. Build whatever blocks you want, start from wherever you want. And that's the fun. If I were to strictly or rigidly define these are the boundaries, then you will not have much say in it. Right? There's no creativity for you to express. So we would like the students to express themselves. I've given you a broad set of guidelines on the kind of blocks that one can build, but after that, it's up to you. How do you want to build it? You want to change the design, you want to change the shape, you can do it. Instead of a cubical block, you may want to build a cylindrical block or like a block which is round, is sphere in shape, or a triangular or a pyramid shape. It's up to you what kind of blocks you want to build, what shape, size, what you want to put in them. You can put multiple devices in the block also. So experiment and try. This is what tinkering is all about, right? You have to tinker, and to try to tinker, you need to experiment a lot, make and break things and see what works best. And what I have given you may or may not be the best for you. So try it out and learn from the experience. And in the process, you are learning the art of designing. This is not just about tinkering alone, right? You're also learning how to design a product, because the tinker blocks can become a product and you can also sell them. So you, in a way, you can also learn about entrepreneurship through these blocks. If you can build a few blocks, assemble them into a toolkit, and you can package them and sell it, then you can even become an entrepreneur. So there is a lot of possibilities that will open up. If you want, you can even get a 3D printed blocks. So all of these are possible.
Sure.
So,
Arunima, please go ahead. I think you also have few questions.
yeah, so firstly, thank you so much for such an amazing session. You talked about a lot of applications, right? AR, voice module, soil, a lot of like, it's nice. But my
Yeah.
question is like, what are some of the pitfalls or drawbacks you can find while, accelerating tinkering with blocks? And if there are
Uh-huh.
some, then limitations as well. How do we mitigate them?
Okay, I don't see any drawbacks or limitations as such, because the only limitation which I talked about earlier is the when you are using Tinker blocks to innovate, you're not focusing too much on the technological part, because once a circuit is built and assembled inside a block, you don't have to focus on the technology part anymore. You focus more on plugging one block to another to realize the functionality that you desire. And when you have to accelerate, this is how we need to do it. Let's say if you want to build a car, you don't start manufacturing, the car company doesn't start manufacturing the tires and the steering wheels and the seats and everything. They just leverage, they have partners who will actually build the seats or the steering or the engine and things like that. All we need to do is assemble them together. That is how the companies work today. The old ways of doing things is not going to work anymore, because if you have to compete in the world where innovation is happening at a very rapid pace, we cannot work from scratch. We cannot build things from scratch. We need to rely on what somebody's already built or what we ourselves have already built, and we have to plug them together and build bigger innovations. Otherwise, I see students doing the same smart dustbin project year after year, right? So the same projects are repeated. Why is it happening? Because students are not leveraging their past work. If you build a smart dustbin project using an ultrasonic sensor or a motion sensor and in a servo motor, You should put them into a block. Next time you can take that and build something else even bigger. If you don't do that, every time you have to reinvent the wheel. Every time you need an ultrasonic sensor, you start putting the circuit. It takes time, and students don't have much time in the ATL. So rather than seeing any disadvantages or drawbacks or pitfalls, I see this approach as as an advantage for students.
It actually
Uh,
is so. And
uh,
about the compatibility also, like there's no issue in the compatibility part as well, right? I mean, plugging it from the prior projects, you can just, make it an advanced one.
yes,
So, yeah.
exactly. You can just plug one set of blocks to another set of blocks, and you can keep extending. You can get multiple functionality. We call this in the software field, we call this as a service-oriented architecture. So when you had to build an architecture for something, every set of blocks or some functionality becomes a service. That service provides you some functionality, and that functionality is taken and plugged with another functionality to build a bigger system. So that is how we go about. We see that in every field, whether it is in the house construction, whether it is in the manufacturing sector, everywhere. Nobody builds from scratch today. It's impossible. Otherwise, we will not be able to run the economy if be able to even complete a project if you have to build everything from scratch. So students have to realize that they have to play the long game, where they start building things, leveraging it, reusing it to build the next project and the next project and next project. And they can also collaborate and share their blocks with other students so that as a collective, they can build bigger innovations. Whether even in the technological field, whether it is AI or IoT, all of these have not been built from scratch, right? They have been built on top of the previous work of the other people. Just take the case of a computer. The computer in the initial days when they came, maybe in the 1950s, 60s, 70s, they were all very tiny, small microcontrollers, microprocessors. And then came the disk operating system, what we call DOS. And then Bill Gates built the Microsoft, the Windows operating system, which was building on top of what was already there. And top of the Windows operating system came multiple apps. Even if you see the smartphones, the core is the hardware. On top of it is the Android or the iOS operating system. On top of it, we have the apps. So the apps are built by somebody. The Android operating system is built by somebody. The hardware is built by somebody. The device drivers are built by somebody. So everybody has to build on top of each other to come up with the next level of innovation. If everybody, even the app developer, had to build the hardware himself, it would take them a lot of time. If the app developer had to build their own operating system, it would take them a lot of time. So leverage and reuse and collaborate, that is the mantra, I would say. Only then we will be able to achieve, build bigger innovations that make actually true difference to the society. Otherwise, it will be just a lab project, which will just die out after the project is completed. You showcase it in a competition and you just throw it away. That is what is happening today for most of the student projects. They just throw it away after the project is done. So there's no long-term thinking of how we can build on top of the previous work. Yeah. So I hope I have answered your question.
Yes, sir.
All right. Thank you.
Arunima, you have any other question, Ritu?
No, Riddhi, for now, I don't have any.
All right. So there are few more questions, but we'll take just last two questions and maybe
Sure.
few can merge both of them. So one thing is like during any project or prototype building, students usually work in the team with different level of, some are beginners, some are at advanced stage. So when we talk about the team context and we design the Tinker Blocks toolkit, so how do we accommodate the participants with different backgrounds or skill levels? So
Yeah, sure. In fact, the Tinker Block is meant to accommodate a diverse team where some are beginners, some are more experienced. So one simple way to handle a project with this is let the seniors take up building some of the blocks and let the juniors test the blocks. So they get the experience of how the blocks work, how the blocks function, and so you need greater experience for building the blocks than testing the blocks, right? So everybody can play a different role. Some can be doing simpler things, simpler jobs, and somebody can take up more complex jobs, and they can share the load. Um, if you already have some blocks, the juniors can take it who don't have much experience. They can start plugging the blocks and seeing how they work. After, are there any limitations in the blocks? Are they really doing the job? Are they addressing the problem statement correctly? Those are the things that the juniors can start doing, while the seniors who are more proficient in technology, they can focus on building the blocks itself or adding the virtual blocks, which are even more complex. So they have to distribute the load according to their skill sets. Whatever skill sets they have, they can play either at the technology end or at the prototype end or at the ideal end. So they can, this is how they can work. And everybody has a play in when you're working with Tinker blocks, either using it or building it.
Hmm. Sir, the questions are not ending, and we have already exceeded that 10 minutes time. But yeah, so this time is the last question, and I'll merge two or three of them together. So
Sure.
it's like what role does iteration and failure play in rapid tinkering workflow? And how do we ensure that participants don't get frustrated by repeated failures? Like, should we encourage incremental debugging, or should we start from the scratch while playing with the tinker blocks? This is one part of it. And second, while concluding, you can say that when the session ends, what practices or the follow-up habits would you recommend so that the tinkering momentum does not get lost and participants keep on exploring and tinkering with the tinker blocks?
Okay. And what was the first part?
So that was about how can we keep them motivated, and while we talk about the rapid tinkering workflow, what role does iteration and failure play in rapid tinkering?
Okay.
Should we encourage the incremental debugging, or should we start from the scratch in case of any failure? What practice should students, tinkerers opt for?
Okay. See, I would say working with Tinker blocks is not very different from the way you traditionally tinker. If you see the building blocks for tinkering today, they are your sensors and actuators and the microcontrollers. That is what we use, and the jumper wires, the breadboards. That is our building block. And if you go back like some 20, 30 years ago, when I used to when I was doing my engineering course, we used to play, we didn't even have an Arduino board. We didn't have a Node MCU. We didn't have any of these kind of devices. We had to play with very rudimentary devices like transistors, integrated circuit chips, capacitors, inductors, and things like that. We had to build and tinker and build solutions with those. But over a period of many years, a few decades, the building blocks have evolved and they make things much simpler for a student to build today because you have a ready DIY sensor or an actuator or a Arduino kind of board, which is like a full-fledged computer, pretty much a small computer in a small matchbox size dimension, right? So it's just that the building blocks have evolved, but the concept of tinkering itself has not changed. So whatever failures you had earlier, those failures can also happen now. But the failures are nothing to do with tinker blocks as such, or the building blocks as such. It is in how you are actually trying to realize your solution. If you have good clarity on how to build the solution, then you are minimizing the failures. At the same time, Tinkerblocks helps you limit certain types of failures because when you are tinkering with simple breadboard wires and you're connecting the jumper wires, you can make mistakes in connecting the wires. For example, if you connect a positive lead to the negative, negative to the positive, you mix up the wires and you connect the power supply, the circuit can burn. If you connect positive to negative, negative to positive, your sensor can burn up, your Arduino can burn up. I see when I visit ATLs, I see many Arduinos fried up actually. Why? Because students have made mistakes in connecting the wires. Okay, but Tinkerblocks avoids that because those wiring is already done once, and beginners don't have to struggle with those wiring things. But maybe when they evolve and they want to go and learn more, then at that time they can understand. So the purpose of Tinkerblocks is slightly different. It's not to avoid tinkering itself. You still tinker. You tinker at a higher level. Instead of tinkering with the technological level, you tinker at the idea level, at the design level, at the prototype level. So your tinkering has gone up. You're no more tinkering with very rudimentary things. You're tinkering at a higher level. That means your critical thinking skills will improve. Your creative thinking skills will improve. You're no more constrained by the technology. Technology is taken for, I mean, it's given. But now it forces you to think creatively. How can I use these Tinker blocks to build my application, to build my innovation? That means you're focusing more on your idea rather than have to struggle with the technology. So Tinker blocks is not eliminating anything. It's actually making certain things simpler, but it is raising the bar for your critical thinking and creative thinking skills. And those are the kind of skills we need today. Because technology, like even if you look at AI can mask many things. So people might say, why should I use AI? Similar, I'm asking a similar question. AI can do many things. Why should I use AI? I want to do things manually because I can tinker better. If that is the argument, then you will be slow. Before you actually can build something, somebody else would have built something better and smarter with Tinker blocks or with AI. And they will go to the market and they will win the competition and you'll be left behind. So if you want to catch up with the rest of the world, you have to speed up your innovation. If you continue to work the old ways, you're going to be very slow in realizing the results. And by the time you come out and show your prototype, maybe there are hundreds of other prototypes which other people have already done and in a smarter way. At the end of the day, it doesn't matter whether you know so much about technology or not. What matters is, have you solved the problem with an innovative solution? So technology is not so important compared to problem solving and innovation. Innovation is more important than technology. And if you want to get stuck with technology, yes, you can. But at the end of the day, who cares whether you know technology, whether you don't know technology? All the world cares is, have you solved a problem? Have you innovated and brought something meaningful to the world? So that is what matters more. Otherwise, I could be sitting and writing assembly code also today. I don't need to write in fourth generation, fifth generation programming languages. I don't need Python. I can go and write in hexadecimal numbers if I cared so much about technology. So technology is useful, but don't get stuck up with technology itself. Technology is only an aid. When the technological building blocks evolve, we also have to evolve and we have to innovate at a higher level. And we should not be stuck with technology. So that is my thinking about this. And
And
what was the
also, sir,
second part, Shruti?
to add point, it also addresses when we talk about pan-country operations here, it also addresses the resource scarcity, particularly in frontier region. So this is
Yeah.
also what I feel is a good differentiator here. That
Yes.
for the
Yes.
talks, yeah. Second question, the second part of the question was like what while the session is ending, what practices or follow-up habits do you recommend so that the tinkering momentum with the tinker block that doesn't get lost and participants keep on exploring and developing upon this idea of rapid prototyping?
Okay. So I missed the actual question part of it.
Yeah. So it's like what practices would you recommend when the session is ending so that the momentum of this rapid prototyping builds up and it doesn't get lost and the participants keep on exploring and creating using the tinker blocks? What
Okay.
yeah, follow up habit or the practices would you want to convey to the students when the session is ending?
Okay. Sure. Sure. So certainly, what I can say is this is just a starting point. What I have given in the last three sessions, I've shown you how you can build Tinker blocks, but I would encourage you to build your own Tinker blocks the way you would like to build. build multiple types of sensors and actuator blocks, and maybe bigger system level tinker blocks as well, which has multiple sensors and actuators and can accomplish a complete system functionality. So continue to evolve this tinker blocks concept and build more blocks, and continue this practice of building higher level building blocks itself. So that is a key practice, I would say. You need to come up with the next level of building block. Don't be happy or satisfied with what we currently have. Think how I can speed up certain things, how I can innovate faster, how I can build things better. So that is the thought process. You need to step back from the actual project itself and look at how I can do this better, faster, not just for this project, but for future projects as well. So your critical thinking has to improve that way. So that's what I would recommend, that students start thinking more critically as a practice in order to evolve and design these blocks further, so that they can move towards more rapid prototyping based development of innovation.
Yeah, thank you, sir. Thank you for answering all the questions and taking up this 3-episode series of Tinker Blocks with the rapid prototyping and accelerate the innovation. And it was an insightful session for all our young innovators. And we hope all our listeners, all our young innovators, students, mentors, teachers, they leverage these learning resources and create innovative projects, for solving community problems. This is what the entire is regarding it. And we look forward to seeing you all in our upcoming session of Knowledge Hub and Mentoring Hour that we put online every Friday at 4 p.m. And thanks, sir, for taking out time for taking this series. Thank you so much, everyone.
Thank you. Thank you so much, Riddhi. Thank you for the opportunity. Thank you, Atal Innovation Mission. So, yeah, good luck and all the best to all the students, teachers, and all the participants. So go ahead and tinker, build more tinker blocks. And I would like to see many of your tinker blocks being presented in a future session, possibly.
Yes, sir. Thank you, sir. Thank you so much.
Thank you. Thank you.